Okay, question 3 now. A 40-kilogram girl sits at the end of a 3-meter long swing, and her 100-kilogram father gives the girl a push. What is the moment of the force provided by the father? Okay, so swing looks like this, and she sits at the end of it, and that's 40 kg, and this is 3 meters long, and the father gives it a push with 100 newtons. So the line of action is 3 meters, and the force is 100 newtons. So for the first part, the torque, the turning force, is 100 times 3, so 300 newton meters. Part B, the girl and father swap places, and the girl pushes the father with a force of 25 newtons. What is the moment of the force provided? So in the second part, the only difference is the force here is 4 times smaller. It's only 25 newtons instead of 100. So that will make 75 newton meters in total for part B. Okay, part C now. The girl sits at the end of a 5-meter seesaw. What is the turning force she is providing? So 5-meter seesaw would look like this. 2.5 meters either side of the turning point. If she sits at the end here, the force that's turning the seesaw is her weight, which would be 40 G. Now, in this picture, you actually have a choice where you want to take the turning point. So, naturally enough, we should take it at the pivot here in the center of the seesaw where the turning effect is, but there's actually no rule that says we have to. So, to be clear, I'll say the torque, and I'll just put it at the subscript center here. That would be the force, which is 40 G, times the distance, which is 2.5. So I think that's 981 newton meters. Let's just quickly check that. 40 times 9.81 times 2.5 is 981 newton meters. So that's right there. The father joins her on the other end of the seesaw. What is the turning force he contributes? So again, for the next part, the only difference is the weight, and he has a 100 G weight. So this is the girl, then this one here will be for the father, and again we'll take the center as the turning point. So he is 100 times 9.81 times 2.5. So that is much larger, 2,452.5, or 53 if you want to round it off. Now, because she is turning it anti-clockwise, and he will, she's turning the seesaw clockwise and he's turning it anti-clockwise, we should indicate the difference by putting a minus in here. Okay, finally, F. The father and daughter now sit on the swing together, and he pulls them back by 30 degrees. At this point, what is the moment of the force acting on the swing? So the picture looks like this now. There's a total downward force of 140 G, which we can resolve into 2 directions, this way and this way. And this one we don't care about, because this force doesn't add to the turning effect since it passes through the turning point. So it's only this one which we're interested in. If this angle is 30, then this angle here is 30. So that makes this one 140 G sine 30. And the distance is 3. So multiplying that by 3. Times sine 30. And that is 2060 newton meters is the turning effect there. Okay, so 2060 is the moment, the torque for that particular one.